is that?
15.
15.
It was the,
Second.
you see how you have like the
Minus
1 minus f a dash, or
this one? The third
no,
one?
the two down.
Well, number 5.
Yeah, the fifth one.
1, 2, 3, 4, 5. Yes.
You see how it says like that, like dash after the a. It was my understanding that it's like
A minus
approach
is start from the left.
starts
left
like,
and
does
E.
it approach from the left
Yes.
to the number?
Yes.
Is there any way you could give like a visual representation? Because I'm a little
Let's
confused.
say this is discrete case. Let's say this is discrete case.
Mhm.
This is 5. That means it start from what? 5, 6, 7, 8, 9, 10. So now this number less than 5 for discrete, less than 5, it should be what? Up to
4?
yes, 4. If that's the discrete. If this is continuous, less than or equal to 5, this is also 5. Because that's
okay.
or equal to 5. The number less than or equal to 5, I spend more than or equal to 5 hours to complete my assignment 3. So that means it's what?
Pardon? Well, could you repeat it?
If this is 5, if for the continuous case, this is also 5.
Yeah.
Yeah, you agree? Yeah?
Yes.
Yes. Okay, good. Okay.
All right. Thank you.
You're welcome.
Professor, for the page 12.
Which one?
Page 12.
Yeah, I know page 12. Which one? Is it lecture 3 or lecture 4?
Lecture 3. Lecture 3.
Okay, yeah, sure. 12.
So for the function.
Yeah, PDF, yes.
For this function, why there is no x equals to 1 and equals to 3?
Doesn't matter. You want to put equal sign, that's fine, because this is continuous case.
Okay.
Yeah, okay. Continuous fine. Yeah, continuous, some people, they say x is more than 1. For continuous, I spend more than 1 hour. Okay, more than 1 hour, they mean 1.000001. You're not going to write this number, you're going to write 1. So x equal to more than or equal to 1. So for continuous case, both are okay.
Okay. For the assignment, I cannot understand what the question asked. For the assignment question 5.
What's the question number 5?
Choose 2 balls from pink.
This question is very interesting. You first, I can give you a hint. Either you use combination or permutation. So you have to know whether order is important or not important.
Okay.
I think the process, the first they take it out and then put it again, and then after that they put it back. Yes or no?
Okay, you mean
then they choose again. If I'm not mistaken, the whole process.
I think like you have to determine like how much you can win in total and how much you can lose in total. Or,
yeah, I think so.
or you can not win any money at all.
That question is very interesting questions. I can give you a hint, either combination or permutations.
Like first, I think you should determine what values x should hold, and then work from there, find the probabilities of each.
So you mean we pick these 2 balls together? Like
yeah, without replacement.
Or 1 by 1 or together?
Yeah, 1 by 1.
1 by 1.
So like, for example, you pick a blue ball for the first time, and then you pick an orange ball for the second pull, how much you would get then.
Okay.
Something like that.
Okay. Okay, let me think about it. Thank you very much. And for the question 4, we need to the seller only sell 1 machine, right?
I think they can sell 1 machine, 2 machines, or 3 machines.
So
Because they got 2 appointments. Yes or no?
yeah,
But it can be both. I think they got 2 models. I cannot remember what's the model.
yes, 2
Deluxe
models.
Standards, yes.
So if totally I sell 5, okay, I see if I sell 5 lecture model, that's 4,000. The
It can
the
be
total dollar value is infinity. So I don't understand what the
it
question.
can be both are expensive one, can be mixed, expensive and cheap, and or both cheap, or maybe only sell 1. So I think they got a few possibles.
Okay. So what is the total maximum value?
Good question.
I can 8,000, 4,000. Yes, it's infinity. So I don't understand.
Otherwise, I take away your learning opportunity. Okay, I give you some hint. Just give me a second. Okay. For the probability, probability distribution fund table. Okay, I need to get another one. The value of the x cannot be 0, 1, follow the sequence. It might be jump from what? $100 to $400 or $500 or to $900, for examples.
Yes.
So the number here is not follow the sequence, it's not 1, 2, 3, 4, or 100, 200, 300, and 400. It's like they jump from one number to the other numbers.
Yes.
And I answer your questions?
Yeah, I mean the last one. The last one
I
is
cannot tell you.
8,000 or
I can tell you. If I tell you, then I take away your learning opportunity.
Yeah.
You think about it. The question is not complicated. I did give you a hint. Is that okay? You can discuss with your friends.
Okay.
I don't want to take away your learning opportunity. Otherwise, at the end, I learn a lot of things. You learn nothing. Yeah.
Thank you.
Yeah. Any more questions that I can help you? Assignment, anyone? My explanation, is it useful or not? I wish I can give you a final answer. If I give you a final answer, then you have no chance to learn. Oh, now it's 11:30. Oh, I should start the class. Okay. Okay, let's start the class. Sorry, I thought we are still in office hours. Anyone want any questions? Yeah. Test 1. There's one TA marking the last questions. She might finish tomorrow. Do you want me to release the mark tomorrow or after the weekend?
The earlier the better, I feel.
Earlier is better. I want you to. I see some students did very well. Okay, some of the students very fantastic. Anyway, if you get below average or very high marks, this is just early feedback. Okay, it's not the end of the world. Okay, you still get another 75% to go. Is that right? How many percent for this test? No, this test only 20%, not 25. Yes or no?
Yeah.
So, okay, so you get low mark, you find the reason why you get low mark. Okay, you get high mark, you also find out the reason why you get high mark. You can email to me, oh, these few chapters are easy, that's why I get high marks. So even though you get low and high, you have to find out the reasons. As I said it, you still got 80% to go. It's not the end of the world. I believe I told you before in this course, I told you in 1994, 27 years ago, I failed my midterm. My midterm is below 50, but end up with the B+. Let me see, chapter 4, yeah. Okay, but one thing you have to know, okay, you need to find a reason. Okay, if you cannot understand all the concept, then you have to let me know. You email to me, okay. 70% left after 2 assignments. Yeah, of course, your first assignment is 2 assignments. You don't tell me that you get 0%. Yeah. So assignment, the first 2 assignments, definitely you get some marks, maybe 8 out of 10 or 7 out of 10. Yeah. So that's your test, you get 50%. That's it. Okay. I saw quite a lot of students get very high marks. Okay. Some students get low marks. So but if you fail your midterm, you have to find out what's the reason. Okay. You really cannot understand all the concept, then you have to talk to me. Okay, see whether you should continue or not. You don't say, oh, my prof told me, said, oh, he failed his midterm, but end up with B+. It's not all the cases. Yeah, okay. Okay. Can I ask you questions? Let me go to this page. I think we finished binomial, yes or no? Can the midterm answer also be uploaded? Yes, yes. Give me a couple of days, yeah. Wait, it's a question I want to. Okay, can you see the? Can you see this page 36? Yes or no? Yes.
Yeah.
Okay, can you go through the questions? Yes or no? Can you understand the question? Let's study normal distribution. Normal distribution, the bell curve. After you study about normal distribution, you don't want me to bell curve.
Sir, I think we stopped at around slide 13 last class.
Huh?
I think we stopped around slide 13 last class.
Say again?
We didn't get until slide 36
Yes,
last time.
yes. But I purposely wanted to talk about this one first before I
Okay.
start with the normal distributions.
Okay.
Yeah. Yes, but yesterday we still can solve it. But can we solve this question easily? Let's say X is what? Binomial. And this is N is what? 80 people. And then this 0.76. Okay. A more than 65. X is more than 65. That means it starts from what? More than 65, that means we start from what? 66. Okay, thank you. So X equal to 66 plus 67 until what? x equal to 80. Yes or no? Okay, so now I think a lot of work to do. So I do complement. Is that okay or not? Can I do complement? Everyone agree? Yes? Everyone agree complement? Okay, let's do complement. So 1 minus what? 1 minus x equal to 0 minus x equal to 1 minus x equal to 2 until what? Until 65, yes or no? So if you compare 1 and 2, which one that you want to use? 1 is the second even worse. Yeah, this is even worse. Yeah, but this is no good. Okay, this is no good. So we don't want this one. So what to do? We give up these questions. The question is no good. The question is no good. Do you agree? Yes, you agree the question no good. Yes, don't give up. Okay, we can use another method. That one we call normal approximations. Normal approximations. That's why I put these two concepts, these two distribution together. We use normal approximations. So for normal distributions, we need two parameters, mu and standard deviations. Mu and standard deviations. Mu and standard deviations. So binomial, mu that means is average or expected value. Okay, so let's say this class I got more than 200 students. Yeah, okay. That's why every time the test paper I cannot give you on time. Okay, yeah. So 200. Let's say I got 200 students. In the past, 90% of the students get A. In the past, 90%, yeah, mean or mu. This one we call mu, okay? Not meow, mu. Okay. This class, I got 200. Of course, it's more than 200. I make it simple. 200 students. In the past, I got 90% of the students get A. So how many students that you expect to get A in this class? Yes, what's your questions? Amina? Yes, there's one student want to ask me question. 180, yes. How do you get 180? Yes, Amina, what's your questions?
I don't have one, sorry.
Yes?
Nothing, never mind.
Oh, never mind. Okay, okay. So 180, yes. 180. How do you get 180? This number multiplied by this number, yes or no? Yes. So this is N, this is P. Okay. So you see, before you study probability, you know a lot of formulas. Okay, there's a formula. We do know that this is in fact is a binomial formula. Yeah. Okay. Yes. MP. So our mean is MP. Our standard deviation is square root of NPQ. Yeah. So we need this two parameter. Do you know the meaning parameter or not? Parameter, are you okay with the term? Okay. The calculations based on the populations. The calculation based on the populations. The input into a functions is input. Functions or input. Yeah, almost. But in general, parameter refer to the calculation based on the populations. Okay, so binomial But usually we cannot get parameter. It's very hard. Okay. That's why we use approximation. So parameter binomial, the P is what? X divided by, if we know the probability n. Okay. So let's say in the past, student took this course, Math 2030 in the past, 20 years. Oh no, it should be more than 20 years. I took this course is 27 years ago. Let's say 30 years. In the past, we got 5,000 students to this course. Okay, so 4,500 get A. So then your P is what? Is that 0.9? Yes or no? So the calculations based on populations. But if you couldn't get the populations, then with no choice, then we get the sample calculations. Yeah, so the calculation based on populations, then we call parameter. Yeah, but in reality, it's very hard. Okay, especially when your population size is very big. So the calculation based on population we call parameter. The calculation based on the sample, then we call statistics. So far, so good? So we need to know mean and standard deviation. Why? Because normal distribution got two parameters, mean and sometimes they call standard deviation, sometimes they call variance, the same. Okay, mean and standard deviations. They need two parameter. Okay, if the mean is changing, then what happened to the shape? If the standard deviation changing, what happened to the shape? So what do you think? If they say mu the same, both mu is mu1 is 7, standard deviation is 10. The next one, mu2 is 7, the standard deviations is, let's say, 3. Okay. So this one, the standard deviation is smaller. Yes or no? So the spread less compared with this one. This one, standard deviation bigger, so it's spread bigger. How do you know? How do you know spread bigger? Let's say I give you two graphs, this one and this one. Which one spread the most? 1 or 2? 2. Yes. Why is 2? Why not 1? How do you know it's 2? Why is 2? Because the information on the horizontal line is bigger and bigger. Is that right? This horizontal line is smaller compared with this one. Yeah. So that's why if I give you these two, the first one should be the second one. The second one should be the first one. Okay. The mean is at the center. Okay. The mean is at the center. Yeah, for the normal distribution. Yes, the standard deviation larger, then it spread bigger. Yeah. Okay, I think I give you the pictures. Now, okay, now. I still left how many more minutes? 25 more minutes. I hope I can stop the time. The time is a constant, then it's good. But the times never be constant. If time is constant, then it's good. Okay. Okay. After the class, I show you my thesis. Every distribution they got functions. Okay. This is one of the functions. Okay. And then the area under the curve. The area under the curve is what? Probability value. Yes or no? The area under the curve is a probability value. We want to stop time too when we do. Okay. Second test, a lot thinking. Okay. I do not mind to give you a little bit more time, but I want to make sure that you don't have class after 12:30. Okay, anyone got class after 12:30? You, then it's very hard for me to give you extra time. Yeah, it's very hard for me to give you extra time. I would like to give you extra time. You don't mind? Okay, email to me if you mind. I don't mind to, because probability sometimes you need a bit of critical thinking. But don't think too much, okay? Don't think. Yeah, just you check the test date. I cannot remember when is our second test. When is our second test? No, we cannot start earlier because I know that many students got class. Oh, no, don't email to your prof. Then your prof might be very upset. I took away their time. Yeah. November 17, November didn't have much time for test one. If the test one, I will give you a lot of time. November 17. I tried to give you a little bit more time for the second test. Okay, you check with the other course, if you got class 12:30 to 1:30, see whether you got test on the date or not, on November 17th. Yeah, but some students, they got tests on the day earlier, so they cannot leave. Yeah, okay, just email to me, see whether you are okay to stay a bit longer on November 17th. If one person say no, then I can give you additional time. Yeah, okay. All the distributions, we have functions. All the distribution, we have function. Maybe I can show you now. Okay. Can you see this one? Yes or no? No? How about now? No, you cannot see. Oh. How about now? Can you see? Oh, sorry. I need to put here. Can you see it? How about now? Can you see it? Yes, sir. You see the functions? Yes. So different distribution, they got different functions. Okay. But all the function, if you do the calculation of probability at the end, you have to do happy Halloween. Okay. At the end, you need the integration is not easy. I can show to you. Okay. Just give me a second. Huh? This is integrations. Can you see the integrations? Can you see the integrations? I need to respond. Yes or no?
Yeah, I could see them.
Yes. Yeah. So the integration, this integration, I think I spent more than 1 week to do it. Okay. Is integration by part. So all the functions, if you calculate the probability, the total probability always equal to 1. Okay. I think I show you here. Yes. The integrations. Okay. The integration at the end is equal to 1 because the total probability always equal to 1. So again, this is approximations. In reality, the model that we have, we cannot have 100% normal distribution or 100% binomial. That's why they use the symbol of this one, approximately, okay, close to, okay? So here we got mean, then the second one is variance. That's why in binomial, I need to teach you mean and standard deviations or variance in order for you to use normal approximations. Yeah. So now these two parameters. Okay, so if your mean is changing, the mean is changing, that means you change the location, yes or no? You move this one to the second, to the third. Let's say the first mean is 7. The second mean, can it be 5? Let's say the first one is 7. The mean for the first one, 7. The second one, can it be 5? No, it must be bigger. The same thing. The third one, let's say this is 7, this is 10. How about the third one? Can it be 9? No. So now you see the locations move. Okay, so mean tells us the locations. That's why if you study, anyone did data management in high school?
Yeah.
Yes? Okay. The calculation of mean, the calculation of median, they call, what do they call? Mean, median, mode. There's a name for these three calculations.
Central tendency?
What's the question? I can't
Is
understand.
it called central tendency?
What's your questions?
Isn't it called central tendency?
Center tendency, yes. And then another name. Measure of what? Start from L. No, spread is standard deviations. Start from L. LO. Yes, measure locations. Measure locations. Like median, you need to find the location first. After that, then you get the value. Okay, that's why the mean, different mean, the location difference. You see, the location move. If they say this is 7, this is 10, this is 10. Cannot be 10, maybe 12. If all are the same, then they have to stay in the same locations. Yeah, so those three calculations we call center tendency or center location, no, measure location. Why they call central tendency? Center, that means middle. So they move toward to the middle. So the calculation of these three in general, not 100%, in general, most of the time is toward to the center. That's why they call center tendency. Yeah, or measure of locations. So are you okay with the first explanations? What is the last one? Cannot see? Which one? Or this one? Mode. Yeah, mean, medium, and mode. This calculation is the easiest one, but it's useless. Why? Why I say it's not useful? Because you can have more than one answer. You can have more than one answer. Like for example, in this class, everyone get different marks. 2 students get 0, 2 students get 100%. So that means your mode is what? 0 and 100. Can you make conclusion about a test based on mode? Okay, let's say now the test 230. Let's say I got 50 students. Everyone get different marks. Only 2 students get 0, 2 students get 100. I still cannot understand center tendency. These three calculations we call central tendency. Center means middle. What is the meaning tendency? Move toward to the center. Yes or no? What is the test average? No, not yet finished marking. So I'm not sure. Okay. Yeah. So center, that means middle. Tendency means towards to the center. Okay, towards. So these three calculations most of the time are at the center. I can show you one example. Normal distributions. Our center is what? It's your median. This is the highest. It's also mode. It's also mean. For the normal distributions, mean, mode, median are the same. So they are at the center. Sometimes, if that's not normal, almost to the normal, maybe the mean close to the center. That's why these three calculations we call center tendency. Measure center tendency. Everyone okay? This is your statistics first year course. Yeah, this is normal. So the normal, the mean, mode, median are at the center. Yeah, okay. The second one, so far so good. Any more questions? I need to respond, yes or no? No question or got questions? Can someone respond to me? No question, okay, thank you. Okay, so the second one, are you okay with my explanations? Okay, some of them is very close, some of them is far away because you got different standard deviations. Okay, we do the integrations, we get 1. Okay, yeah. Okay, now if this is about X is about income. Income for what? For computer programmer. You guys are computer science students? Yeah, okay. That's the income for programmer. Yeah, it's normal distributions. Okay. So maybe the X is referred to the income. X is referred to the income. So your normal maybe is average is how much they make now? Once you finish your study, how much do you think you can make? 70,000? Average, yeah, 70,000. Okay, 70,000. And then some people might get 71, some people might get 68, 69. So the standard deviations or variance is, let's say 4,000. Okay, yeah, 4,000. So we know that for normal distributions, the mean is always at the center. So this is 70,000. Yeah. Okay. So we can do the transformation. We can change it to X to Z. Maybe we can change it to X to Z. Okay. Now this is X. Now I change to Z. Okay. This one we call normal distributions. Okay, not normal distributions. Now we change it to standard normal distributions. Z is stand for standard normal distributions. So now for standard normal distributions, your mean is always 0, your standard deviation always 1. Yeah, okay. So now let's draw our pictures. So our center is always equal to what? According to this one, your mean is 0. If this is 0, this number on the left-hand side is what? Not minimum mean, not minimum average. This is not minimum, okay? This is, okay. Mean, this is variance, okay. So this is 0, that means the number is negative. The number here is positive. Okay, so here I cannot put X anymore. I should put what? Z. Okay. So I do the transformation from X to Z. Okay, when I do transformation, this one becomes 0 and 1. no matter what's your mean, what's your variance, if you do the transformation, this is 0 and 1. Okay, this concept is very important. This concept is very important because it helps us to use the table. Can you see the table? Can you see the table? I think this PowerPoint
Pretty
is
blurry.
hard to see.
It's pretty blurry.
I think in your textbook, yeah, this is your table. Okay, so in this code, if the variance is x, we want to calculate the probability, we need to transform or change it to z. Yes, I can zoom it. I think still very hard to see it. I make it bigger. Okay. Can you see it? Is it better now? Yeah, okay, yeah. So we need to use this table. This table we call Z table. We call Z table. Okay, look at the first number. If the Z value outside Z value, outside, inside is a probability value. I know it's not clear at all. Yeah. Inside is a probability value. Outside is a Z value. Okay. Why the Z value? The probability is 0.5. Can you see the first one? Okay. Maybe I erase this one. Here is what? 0.0. Here is 0.1. Also cannot see. 0.0. 0.0 or 0.00. Okay, but the probability is 0.5000. Yes or no? And then the next one is what? 0.01. What's the probability value? 0.5040. Okay, let's talk about the first one. Why this 0? Then this is 0.5. Why this is 0? The meaning of this one is 0.01. The probability is 0.5040. Why? Okay. Now go back to this example. Go back to this standard normal distributions. Here is 0. Yeah, I'm not. Everyone agree? The Z value here is 0. Just now, you remember Z normal is 0 and 1. The mean is 0. This variance or standard deviation, this one should be variance. Variance is equal to 1, standard deviation also equal to 1. Okay. The Z table, altogether, we got 3 different Z table. But if you want to do the calculation, at the end, you get the same answer. Okay. This table is, you see, why they color this part? Why they color this area? This table is
the area.
This table is moved to the left. That means if your Z value at Z is less than or equal to 0, that means move to the left. Yeah. So this part, what do you get? Is that 50%? Yes or no? Okay. Up to now, are you okay with the table or not? I want to make sure everyone can understand my explanation because the table is very, very important for this part. Yes or no? Are you okay with the table? No? Okay, I can repeat. We got 3 different type of tables. We use this table is go to the left. You see the color, the left side. The color the left side. So the table is based on the left one. Okay. So now, if my question asks you, what's the probability Z is less than or equal to 0? Is that this part? Yes or no? This one is equal to this one. For normal probability distribution, because normal probability distribution or standard normal distribution is Continuous. Continuous, that means both are the same. So that means which part that we want? We want this part. Yes or no? Yes or no? So this one, we know the table. Right away, we know the answer is 0.5. Yes or no? Half. We color half of the curve. So 0.5. Okay. Why the next number, the probability value become bigger? Why? After 0, maybe this part. Okay, let's say this part, maybe 0.01. Okay, so now, oh, I bought all the same color marker. I bought 10. They don't have different color. Okay, now, no problem. So here. So now, let's say my question is what? Probability Z less than or equal to 0.01. So now, should I color this one? Yes or no? Less than, go to the left. So now, your answer should be more than 0.5. Yes or no? The probability value. Yes. That's why here is what? 0.5040. That's right. The table is right. Everyone okay? Yes, you have to be careful. We got 3 different type of tables. Okay, use the textbook table. One is go to the left, one go to the right, one go to the center. I remember I took one course in the 3rd year. A 3rd year statistics course in York. Test, okay, in class, to the left. Midterm to the right, final to the center. But you still get the answer, but we have to make sure we know how to use. But in this course, I use one table only, to the left, all the time to the left. So I'm not sure that about the Z table that you put it here, is that go to the left or go to the right or go to the center. But all 3 tables are good. Just like when you do the calculation, you need to do some adjustment. At the end, you get the same answer. Everyone okay? Can you understand my explanations? Yes.
Yeah.
Okay, let's do one more. Let's say do one more. Okay. One more minute. Z is more than or equal to 1.2. What do you think about the answer? Don't do at the table first. This one should be what? The answer. If I told you my answer is 0.4288, can you right away say my answer is wrong? Let's say you know a table, and I told you that my answer for this question is 0.4288. Can you right away say my answer is wrong?
No, yes.
Yes? Why yes? I agree with you. Let's draw the pictures. My answer is 100% wrong. Let's draw the pictures. The center Z is equal to 0. Now 1.2. So 1.2 maybe here. Okay, just roughly. Less than, let me go to the left. So according to our diagram, the answer should be what? More than 5, maybe 0.61 or maybe 0.57. Okay, if you want to get right answer, we need the table. 1.2. That means go to the 1.2. Can you see 1.2? Can you see the value here? I cannot see. Can someone read the numbers? I cannot read the number. It's here. Maybe I make it bigger. I see what.
Sir, it's 0.8849.
Yes, 8849. Yes, 8849. Thank you. 0.8849. Yeah. Okay. That makes sense. That makes sense. Are you okay with the table now? Okay. Now let's say I change your questions. I change it to more than 1.2. If I change to more than 1.2, how to do this one? Complement? Yes, complement. Because here is 0.8849. Okay, so everything is 1. So 1 minus this one become what? 0.1151. Yes or no? My answer is right. Yes or no? Yes. Okay, I'm very good in math. Okay, so I don't need calculator. Okay. Yeah, now it's 12.21. Okay. Are you okay? So there's no problem. If they ask you more than or less than, which you can do it. Okay, now, okay, give me 1 more minute. It's okay. I like to give you a lot of knowledge. Okay. I don't have money, so I cannot give you money. Okay, yeah. That's it. I change the question to this one. Are you okay or not? Do you think we can do it or not? Let's say 2.11. Can we do these questions? Yeah, we can draw the pictures. This 0, so negative 1.3 to what? 2.11. So, yeah, no need to worry. As long as you know how to draw pictures, there's no problem. I will show you how to read the table. You don't see why not? Yes, everything is possible. Okay, probability always equal to 1. Everything is possible. Yeah, no problem. I will show you how to use the table on Monday. Yeah. Okay, so but you have to be careful the table that we use. Test, midterm, no, second test, final, we use this table all the time. Yes, yes. Now it's 12:23. Yeah, okay. So let me do a conclusion for the normal distribution. Maybe someone help me to do conclusions. What we learned today about normal distributions. Z-table, okay, when we can use Z-table, the question always, most of the time they give us X. We need to convert to Z. Okay, one, we convert to Z. What is the other name for Z? Yes, standard normal distributions. One, we convert to Z, then we can use a Z table. Yeah, so normal distribution, they got 2 parameters. What are the 2 parameters?
Mu and variance.
Mu and variance, yes. Mu is tell us the locations. Variance is tell us how spread is that. Okay, is it very skinny or not skinny? Yeah, okay. So remember, for normal distributions, we got 2 parameters, mean and standard deviation, or mean variance. Yeah. So we have to know how to use a table. It's very, very important. Yeah. In order for us to get the probability value. Without Z-table, we cannot get probability value. Because our entire course is about probability. That's why we need to know how to use the Z-table. Everyone okay? Anyone want any questions? Do you think you learned enough stuff from me? Yes or no? Yes, okay. So then I see you again on Monday.